thought I might make a little video to help you with this just in case you need it. So we're going to take a look at lead, and if you need to know how to write the electron configuration for lead, of course you need to know how many electrons are in lead. So I'm going to reach out here and grab a periodic table, pull it in. Here's lead. It's number 82 on the periodic table. This little periodic table is kind of neat because it actually tells you the configuration. So it looks like this. Wait, what's that xenon mean, that Xe? Well, writing this, Xe, is the same thing as writing 54 electrons. See how it's 54? So that's 54 electrons plus whatever else is left for lead. Alright, so we're going to, if you wanted to, you could look at the electron configuration of lead on this chart. See lead right there, and this is the electron configuration. That's what the boxes with the arrows. So let's set that aside. We know we've got 82 electrons that we have to put in. Maybe I don't know if I can keep them all on the same screen here. So I'm going to tell you what I'm going to do, then I'm going to do it. So you'd start with 1s1 and 1s2. So you're just going to go through the periodic table until you get to this red spot down here, which is lead. So 1s2, then 2s2. Remember, this is a S region. Then 2p6. Then the third row, S, with 2 electrons in it. And the third row, P, with 2 electrons in it. Then you have the fourth row with 2 electrons, 4s2. Then you move over to 3d. And your periodic table is noted so that it says 3d right here on your table. So 3d. Then you go on through 4p, also noted right here on your table. So 4p. Then you come to 5s. We're still not to lead, are we? So it'll be 5s2. Then 4d10. Then 5p6. Then 6s. Now on your table, this is a little different right here, because after 6s there's a little cross thing that says to go down to the bottom for the 4f. On this table, it goes ahead and shows us 4f1, 4f2, 4f3, all the way to 4f14. Then we go into 5d. So 5d1 starts here. On your table, then you go down to the bottom for the 4f, then back up to the main table for 5d. 5d goes to 5d10, and now we're almost to lead. We're in 6p1, 6p2. That'd be the last thing for lead. So if we're going to write the configuration out, it would look like this. We'd go 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, that's a 2, sorry, 3d10, 4p6, 10, alright, and then 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p2. So that's the complete electron configuration for lead. For noble gas, remember, the noble gas configuration involves going up to the previous row. So I'm going to go back to my lead over here. There's lead. Up to the previous row here, to the far right end there, and that's xenon. So we're going to put inside the bracket right here, we're going to put brackets, then a xenon, Xe. And what that means is that there are 54 electrons already noted. So let's go over here. Here's xenon. I lost my mouse here. Xenon right there. And if you click on it, it shows 54 electrons. Right here, 54. Alright, so moving back over here, if there's 54, if you count the electrons, you're going to end right here, right after the 5p6. So it'd be a bracket there and a bracket there. So what that means is that everything up to 5p6 is covered when you write xenon in brackets. So what was left over that wasn't in the brackets would only be the 6s2, 4f14, 5d10, and 6p2. All right, so there you have your noble gas configuration. Now, outer shell only involves the outer shell. So you look at this again, then you see, well, what is in the outer shell? Whoops. It'd be the 6th energy level here and the 6th energy level here. So the high outer shell just means what? Highest coefficient. Well, what is a coefficient? Well, coefficient is the number in front. So 6 is the biggest number in front. So you'd have 6s2 and 6p2. That's the outer shell. So how many electrons are in the outer shell? Looks like 2 in the 6s and 2 in the 6p. In other words, for outer shell that I'll be using is valence, the valence shell. So over here when you do dot diagrams, I'm going to put a sample down here. So for some element X, remember we said you'd have the S sublevel, which is the sunny room. Then we'd have the pink room with 3 beds in it. Okay, if I want to draw it with beds, for some element X, there's the sunny room. And here are the beds in the pink room. Remember there were 3 of them. So if I'm going to put electrons in, see I've got 2 in the sunny room. So I'd have an electron here, oops, I have an electron here, and an electron there. Those are the 2 in the sunny room. Then they go in the pink room, and I have an electron here, and an electron here. Having a little trouble with my pen today. And an electron here. So remember, they go into separate beds in the pink room. Right there. All right, so now if I actually do the dot diagram, the way you do it is you put the symbol down. That's lead. The 2 electrons that are in the sunny room, which is these 2 right here, are going to go here as a pair. Then the 2 electrons that are in the pink room have to go in separate beds. So there's a bed on top, bed on the side. So you put an electron on the top and an electron on the side. And that is how you do the dot diagram. So that was a little review. You need to get this sheet finished up and turned in. Please don't forget.